China's LimX Dynamics has just officially launched the TRON 2 humanoid robot, a platform designed to advance embodied robotics research and real-world robot tasks. Let's watch what this robot can do first. This new robot is now open for pre-orders, with pricing starting at approximately RMB 49,800 or $7,000. TRON 2 builds on a modular design that allows rapid configuration for different modes of operation. In China's competitive robotics sector, this launch represents a major development in general-purpose robot platforms. TRON 2 combines multiple mobility modes with manipulation capabilities and is presented not just as a machine, but as a full vision language action development platform for AI and robotics research. This is the world's latest modular humanoid robot meant to be reconfigured for diverse tasks. TRON 2's design includes a universal base and 3 configurations: dual-arm manipulator, bipedal walker, and wheeled leg mobile mode. In dual-arm mode, it operates as a manipulation platform with arms that have 7 degrees of freedom per arm and a reach of approximately 70 centimeters, enabling precise task handling across its workspace. In bipedal configuration, TRON 2 can perform dynamic locomotion capable of climbing stairs and adjusting to uneven terrain. Its wheeled leg hybrid mode supports 30-kilogram payloads and offers all-terrain mobility with adaptive control systems. These configurations allow it to switch between manipulation-focused roles and mobility-intensive tasks, expanding the scope of its applications in both indoor and outdoor settings. The robot's manipulation hardware includes a spherical wrist design on each arm that increases operational flexibility and reach. The 10-kilogram dual-arm payload enables desktop tasks and object handling in research environments. TRON 2 also employs active safety boundaries on its motion system to prevent collisions and automatically reposition its arms safely in the event of power loss. TRON 2 is delivered as an all-in-one vision language action platform that integrates hardware and software for data collection, annotation, training, inference, and task management. The platform includes preloaded algorithm tasks, allowing developers to start experimentation without custom algorithm tuning. VLA support also includes mainstream models and datasets that cover a variety of physical tasks, including object manipulation and environmental perception. The platform provides a full Python development workflow, supports ROS1 and ROS2 frameworks, and is compatible with major simulators such as NVIDIA, Isaac Sim, MuJoCo, and Gazebo. This ecosystem of tools enhances the robot's utility for both research and practical robotics integration. Pricing for TRON 2 begins at about $6,800 to $7,000 for base configurations, which positions it significantly lower than many research robots with similar capabilities. This accessibility could encourage wider adoption among labs, universities, and startups focused on embodied intelligence and applied robotics. The modular nature of TRON 2 is intended to lower barriers to entry for robotics research. Users can configure the robot for different mission types without needing separate hardware platforms. The design is also scalable for adding sensors, effectors, or software modules based on research needs or task requirements. In technical specifications, TRON 2's 7 degree of freedom arms and 70 centimeter reach per arm represent some of the largest workspaces in its class among comparable modular robots. Full field perception is enabled by a front camera system that covers the entire arm span, giving it comprehensive sight for tasks requiring visual guidance. Multiple safety and mobility systems are integrated to support real-world operation. Adaptive control systems adjust the robot's locomotion for variable terrains, and redundant power systems can fold the arms to safe positions when power disturbances occur. These features are essential for deploying the robot in experimental or industrial environments. China's launch of TRON 2 follows other robots from the same company, such as TRON 1, which introduced modular foot-end configurations and motion control for research, and full-size humanoids like the Ollie series that demonstrate whole-body mobility and manipulation. LimX Dynamics' corporate headquarters are located in Shenzhen, China, and the company has emphasized its focus on general-purpose robotics and embodied AI development. TRON 2's development also reflects broader trends in robotics, where modular physical design is paired with software platforms capable of autonomous or semi-autonomous operation. The integration of perception, mobility, and manipulation in a single platform positions TRON 2 as a flexible solution for robotics tasks from research to potential industrial workflows. According to company communications, TRON 2 was introduced ahead of its official launch on December 18, 2025, marking a new phase in how humanoid robots can be configured and deployed in research settings. The formal announcements and early demonstrations emphasize the platform's readiness for experimentation and AI agent integration. TRON 2's hardware and software integration underscores a shift toward general-purpose robot platforms that can handle a wider range of activities without requiring distinct robots for each function. This modular reconfigurability could influence how labs plan robot deployments and develop AI models tied to physical embodiments. The launch of TRON 2 adds to the expanding portfolio of robots developed by LimX Dynamics, reinforcing China's presence in the global humanoid robotics market. Its multi-form design and accessible price point may facilitate broader experimentation with embodied AI and bring more institutions into advanced robotics research. A humanoid robot performed martial arts-style movements in a video that surfaced on December 12, 2025, sparking immediate global debate about whether the footage was authentic or computer-generated. The clip shows Xpeng's Iron robot executing fluid kicks and weight shifts and coordinated upper and lower body motions that resemble trained human movement. Let's watch the video first. Within hours, the video accumulated millions of views across social platforms as viewers questioned the legitimacy of what they were watching. Xpeng Robotics, the division behind Iron, developed the humanoid as part of the company's broader push into artificial intelligence and autonomous systems. The company publicly revealed Iron during its AI Day event earlier in 2025, where engineers opened the robot's casing on stage to display its internal mechanics and prove full autonomy. The demonstration aimed to eliminate skepticism about hidden operators or pre-programmed sequences. Iron stood and walked independently while its exposed systems remained visible to the audience. The martial arts video builds directly on that reveal. Iron shifts its center of gravity while executing kicks and maintains balance during single-leg stances and transitions between movements without visible hesitation or correction. These actions require real-time processing of sensory data and motor control feedback and dynamic balance adjustments. Most humanoid robots struggle with this level of coordination because balancing on one leg while moving limbs demands rapid computation and precise actuator response. Iron operates with dozens of degrees of freedom distributed across its joints. Xpeng equipped the robot with proprietary AI chips designed to handle motion planning and vision processing and sensor integration simultaneously. The system processes input from cameras and inertial measurement units and joint encoders to calculate movement trajectories in milliseconds. This architecture allows Iron to adapt to changing conditions rather than follow pre-scripted routines. The robot stands approximately 5 feet 8 inches tall and weighs around 154 pounds. Its design prioritizes human-scale proportions to enable operation in environments built for people, including factories and warehouses and service facilities. Xpeng has stated that commercial deployment remains the primary focus, with consumer applications considered for later phases. The company targets mass production by 2026 and projects output of 1 million units annually by 2030. Elon Musk commented on Iron's capabilities in November 2025, acknowledging the robot's progress while noting that Tesla's Optimus project continues development. Musk stated that competition in humanoid robotics drives innovation across the industry. Tesla demonstrated Optimus performing tasks like sorting objects and walking on uneven terrain during its own 2025 events. Both companies emphasized the importance of cost reduction and manufacturing scalability to achieve widespread deployment. Xpeng's approach differs from some competitors by integrating automotive manufacturing expertise into robot production. The company applies techniques from its electric vehicle assembly lines to reduce costs and improve reliability. Xpeng produces vehicles at scale, giving it access to supply chains and precision manufacturing tools and quality control systems that translate to robotics. This background influenced design decisions around modularity and serviceability in Iron's construction. The martial arts movements displayed in the December video serve as a benchmark for control system capability rather than a planned function. Humanoid robots must handle unpredictable scenarios in real-world environments, requiring balance, recovery, and obstacle avoidance and adaptive motion. Demonstrating complex coordinated movement validates that the underlying technology can support practical tasks like lifting objects and navigating tight spaces or assisting human workers. Industry analysts note that humanoid robots face significant challenges before widespread adoption. Battery life limits operational duration, with most current models running between 2 and 4 hours on a single charge. Manufacturing costs remain high, though projections suggest prices will decrease as production scales. Software development for task learning and human-robot interaction requires extensive testing and refinement. Safety standards for humanoid robots working alongside people are still being established by regulatory bodies worldwide. Xpeng's timeline for Iron places commercial units in pilot programs during 2026. Early deployments will likely focus on controlled environments such as manufacturing facilities or logistics centers, where tasks are repetitive and predictable. The company has not disclosed pricing, but indicated that initial commercial units will target enterprise customers rather than individual consumers. Mass market availability depends on achieving production targets and demonstrating reliability in field operations. The December 2025 video reinforces momentum in the humanoid robotics sector as multiple companies race toward viable commercial products. Boston Dynamics and Tesla and Figure AI and several Chinese manufacturers announced progress on bipedal robots throughout 2025. Each company emphasizes different aspects of the technology, from manipulation dexterity to walking speed to AI-driven task learning. Xpeng's Iron distinguishes itself through fluid motion and integration with the company's existing AI infrastructure. Iron's development reflects broader trends in Chinese technology investment. Government initiatives support robotics research as part of national strategies for automation and artificial intelligence leadership. Chinese companies have increased robotics patents and publications in recent years, contributing to accelerated development cycles. Xpeng benefits from this ecosystem while maintaining focus on commercial viability and manufacturability. The martial arts demonstration video concludes Xpeng's 2025 public showcases for Iron. The company stated that 2026 will focus on refining production processes and beginning pilot deployments with commercial partners. Further technical details about Iron's capabilities and specifications are expected as manufacturing approaches mass production phases. The humanoid robot market enters 2026 with multiple competitors positioned to deliver commercial products, making the next 12 months critical for establishing industry leadership and proving real-world utility.